Okay, so we've come quite far in building our game already. Let's now look at taking keyboard inputs and moving a sprite or something around our game board. We won't actually be making a game from this, but I think when it comes to actually making your own games, this will be really important depending on what you're trying to build. So let's have a look at an example of what we're actually trying to do. So here I've just got my kind of example grid game working, and what I'm looking to do is have my sprite initialize in a certain square. So I'm just going to refresh this, and at the moment it initializes in 37. I've chosen that, and then I'm using the up, down, left and right arrows to move my sprite between the squares. Now, there are a few considerations that we need to make with this. Yes, we can take the keyboard input and we can update the position of our little sprite, our duck in this instance. But what happens when we get to the left or the right here? Well, we want to make sure that our duck does not move off the grid and does not, say, move from 69 to 70. So there are a few things that we need to kind of bear in mind, but don't worry, we will go through all of that in a moment. Okay, so let's go ahead and just go back to our game code, and I'm just going to go back to the Whacker duck here. So in the last video, we added this add duck function, and this adds a duck class to a cell. So what I think would be a really good idea here is to actually have a variable that will keep a track of our duck position for us. So just under here, and I'm going to leave a space between the const variables that we have and then put in a let variable, because we're going to be updating this every single time the duck moves. So we have a let variable, and we'll call this duck position. And for now, let's just initialize this as, I don't know, something near the middle, let's say 54. So if we save this now, and we call down at the bottom here, we call our add duck with our duck position passed into it, so that it will pass into our function here. Save this and just refresh this page if it doesn't show up. There we go, we get our duck actually initialized at cell 54. So now what we want to be able to do is kind of remove that duck from 54 and then add it again into 55, say if we were moving right, or 44 if we were moving up, 53 if we were left, and 64 if we were moving down, for example. So one thing that we definitely need to do beforehand is we need to make a function that will remove the duck from wherever it is. So there's two approaches that we can do here. What we could do is we could loop over every single cell in our grid and just say remove the duck class from that. There is a slightly better way, I think, of doing it, and that would be to literally just look at this duck position and then remove the class from that cell. So that's what we're going to do. So we'll say function remove duck, and then we'll take that position again, just like we're doing here for the add duck function, and we'll add it in as a parameter, so that if we want to use this somewhere else in our code, we've got it available to use there. And then we're going to add our code block underneath. So I'm not going to bother doing this console.log adding duck just for now, removing duck. Let's just go ahead and write the code that will remove the duck from whatever position we give this function. So we'll say cells at position that we're passing in, we want to edit the class list. We want to remove the class of duck. So what we can say here is dot remove, add some parentheses, and then tell it a string of duck. So this will remove the duck class from wherever the duck is positioned. Give me a quick message if the word duck has lost all meaning to you now. So let's go ahead, and we've added our duck into the duck position here. And then let's just go ahead and remove our duck from the duck position, and then add our duck again into, let's say, cell 30. So if we save this now, this is going to be extremely quick that it happens. But if we refresh the page, I might need to just hold shift and refresh here. Yeah, it's happening very, very quickly. But you can see that we do actually have adding duck happening twice, because it will have added it to the 54 that it was initialized at, removed it from there, and then put it into 30. Don't worry if that doesn't make too much sense now. We're going to see that happen in much slower when we use the arrow keys. Cool, I've just removed those for now. We still want to have this add duck here so that we have it initialized at 54. Okay, so how do we get our keyboard input from the browser? Well, one of the ways that we can do this is we can use something called window.onKeyUp. Now, I'm just going to add this just under here so that we can keep all of this code together. And we can say window.onKeyUp equals, and then we're going to give it a function. Now, this function will come with an event. And the event is kind of the act of us lifting our finger off one of the keys of our keyboard. Now, great. We've got our function. We're going to start our code block with the curly brackets. So how do we get which key has been pressed? Well, I've left a link in this lesson that I would like you to go to have a play with. And essentially what this is a very handy little website that will help us understand exactly what the keyboard events are when we press certain keys. So, for example, if I was to press the spacebar, you'll see that this has got a JavaScript key code of 32. We also get an event location, tells us that it's just a general key. We've got a code for the key, we've got space. If we were to use event.which, we would get 32, for example, and they've even given us a little bit of a description as well. Something to bear in mind here, that every key can have a different kind of associated code or location or which, even if sometimes they do the same thing. So for example, if I press the 0 just above my P key, you'll see that gets a key code of 48. The event location is general keys and the event code is digit 0. But if I was to hit the 0 on my numpad, you'll see that I actually get a completely different set of data, even though the event actually what we're doing is just typing 0. You'll see that it's got an event location now of the numpad and a code of numpad 0 and even a different event key of 96. So just be careful that you might be expecting a 0, for example, but depending on where that 0 has been pressed, you might get different results in your code. Similarly, if I press the left-hand shift here, you'll see that I get a code of 16, but an event code of shift left. If I hit the right hand shift key, the key code is exactly the same. It's still 16, but the location and the event.code have changed to describe the difference in those two keys. So it is important to kind of make sure that you're getting the right thing from your JavaScript. You'll notice here as well, to kind of combat this, you see that the left and the right shift both have a key code of 16. You'll see that it says here event.which and event.keycode are deprecated in modern browsers, and instead we should be using .key, so this one, if it doesn't matter which shift key we've pressed, or event.code instead, which will tell us this shift left and shift right. So that's something that you should bear in mind. The reality is that you may, when you're looking around the internet, you may see people using event.which and event.keycode in their code, and then using these keys as well. So it's important to know that these exist, but for modern browsers, we should be using this .key or this .code right here. So let's have a look at what we will get from the event when we use the arrow keys, which is what we're after when we move our sprite around our grid. So if we use the up arrow, you'll see that our event.code is arrow up with a key code of 38. And we could do left, we get arrow left, arrow right, and down, arrow down. Fantastic. We can use these now to detect when a user has pressed one of these arrow keys. Excellent. So I'm just going to have this on my second screen here, and we'll come back to it later if we need it. But what we can do here is in our window.onKeyUp function, we can say if the event.key is equal to arrow, sorry, we need to type this correctly, arrow left, well, we can do something then. So I'm just going to start my code block in this if here. And let me just move this screen around so I've got a bit more real estate. So what do we want to do? Well, first of all, we want to remove our duck from wherever it currently is. So we'll run our remove duck function, and we will pass it the current position of the duck. So what did we call that variable? We called it duck position. So we save that. Now, when we move our duck left or right, let's just go back to here, to our game. When we move it left, what do we actually want to do to the duck? Well, we kind of want to move it one cell down. We want to remove one number. We want to kind of decrement our duck position by 1. So let's do that. So after we've removed the duck from its current position, we want to change the duck position. We want to say duck position minus minus, because this will decrement that position by 1. And then we want to just go ahead and add the duck back at its new position. So we'll say add duck at duck position. So if we save that now, let's see what happens when we press the left key. Ah, fantastic. We get our duck. Oh, wait a minute. That doesn't work very well, does it? We're moving our duck and continuing to move our duck. So great. Whilst the thing that we've tried to do works, it's not kind of working in the way that we would expect it to. Okay, no bother. Let's try and put something in place that will stop that from happening. So in our if statement, we can put multiple conditionals. So what we can say here is, if the duck is in a square that is divisible by 10, because you see all of these numbers here are divisible by 10, then just don't move the duck. So let's go ahead and do that. So we'll say if the event key is arrow left and our duck position is not divisible by 10. So we'll say duck position modulo 10 is not equal to 0. So if when we divide our duck position by 10, if there is nothing left over, we don't want to do this. So let's go ahead and see. I'm going to hit left, 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 and we can't move any more. Fantastic. So what that's done is it said, hey, this is divisible by 10. 50 is divisible by 10. When I divide 50 by 10, I have nothing left over. So we're not going to do it because I've said when it's not equal to 10, we're going to do this. Great, let's now try moving our duck to the right. So under here, we can say, we could do this in an else if, but I think that's not really, there's not really any point in doing that. We can just say if event.key is equal to, and then let's go ahead and check our checker again. So we're going to hit the right arrow key and we get an event.key of arrow right. Wonderful. Let's go ahead and put that in. So arrow right. Well, what do we want to do? We want to do pretty much exactly the same as this, but instead of decreasing the position by 1, we want to increase the position by 1. So I'm just going to go ahead and copy this code here and paste it in here, and then just change this to increment it by 1. Of course, the eagle-eyed amongst you will have noticed that we will have the same problem as with our decrementing. So our decrementing still works. We still can't go off the board that way, but we can go off the board this way. So have a moment just to think about what you might need to do to detect if this ends in a 9. Okay, let's give it a go. So if we have arrow right and our duck position modulo 10 is not equal to 9, because when we divide 29, for example, by 10, if we get 9 left over, we know that we're in that end block. So if we save this now, let's just double check. So left, yep, I can't go off the board there, and right, yep, now I can't go off the board there as well. Pause the video and try and implement both of the if statements for moving up and moving down. I would recommend that you just get up and down working before trying to write your if statement to stop them moving off the screen. Get the movement working first, then put in those fail-safes. Okay, so I'm just going to run through this now, and we can go ahead. You can have a look and see if you've got a similar solution to me or whether you did it a different way. Ultimately, as long as it works, that's all I'm after right now. So I'm just going to go ahead and copy this and paste it here, and then go and check my key code checker for the up arrow. Okay, so it's arrow up. So we will change this to say arrow up, just like that. I'm going to remove this for now because I'll come back and look at those in a moment. And actually, I'm just going to have a think about how we get this duck position to move up. Well, if I'm moving, say, from 50 to 40, well, that's just removing 10. That's just decrementing by 10. And the same if I go from 45 to 35. That's just, again, decrementing by 10. So that's what I'll do. So we'll say when I hit arrow up, we want to say duck position minus equals, so decrement this by 10. Let's give that a go to see if it works. Hey, fantastic, fantastic. Of course, I get errors if I try and move off the board, but we can come back to that in a moment. So let's go ahead and copy our arrow up and paste it here. And this will be, any guesses? Arrow down. Just like this. And we want to do the opposite. We want to increase by 10. So we'll say plus equals 10 there. Now let's go and test. And brilliant. We can move in all 4 directions now. And of course, we still get our errors if we try and move off the board there. So we just need to make sure that we keep our positions inside the board. So if we're going arrow up, we'll say if the event.key is equal to arrow up and our duck position is greater than 9, so if it is not inside this first row, we will do this. We will actually move the duck position. And when it's arrowed down, we'll say if it is less than 90, because then we know that it is not on this row here. But let's save this and just see if it works. Okay, so it works up. I've probably made a mistake with my moving down. So let's have a look at what I've done wrong. Yes, I've just missed my AND operator there. And duck position should be less than 90. Okay, let's save this now. We still get it initialized there. Fantastic. We can now move down and we cannot move off the board. Fab. We can move in all directions. Make sure that all of our corners work. And there we go. We can move our duck around the board.